Yeah, Bismillahirrahmanirrahim. Thank you very much, the chairpersons. Uh, Prof. IR Dr. Rupita. Assalamualaikum and very good day, a very good afternoon to everyone. So I am Asurani Binli, and the focus of this thesis is the distant aware bidirectional medium access control for the mesh wireless network on chip architectures. So this is the outline of my presentation, which basically consists of five main parts, which are introductions, the proposed BMAC, the proposed DA plus BMAC, result and discussion, and I will end up this presentation with the conclusions. So without further ado, I would like to begin this presentation with an introductions. Network-on-Chip or NOC have gained a strong establishment as a viable solutions for future on-chip interconnected networks, and it adapts the application of networking theory, which is based on packet switchings and consists of a number of routers interconnected with point-to-point links that then can be arranged to form a specific kind of topologies. Uh, for example, mesh or small work, for instance. NOC is the preferred choice for CMP because it can provide on-chip interconnected scalabilities. However, as the number of core grows, the performance benefit of these conventional NOCs is restricted by the high latency and also high power dissipations, which is mainly due to the long distance multi-hop communication across the chip. Wireless network chip, or in short WiNOX, is the NOS architectures that hybridize the wire as well as the wireless interconnects in order to alleviate the multi-hop wire communication latencies through the long-range wireless channels. Moreover, with the advances in the integrated transceivers, together with the millimeter wave antennas, these have motivated the development of WiNOX as a possible complement to the conventional NOC. Meanwhile, in WiNOC, a set of processing cores are integrated with on-chip transceivers for modulations, which is then can be able for data for transmit its data packet wirelessly. So why not is interesting in the recent research due to several factors. First, why not is CMOS compatible. This means it can be employed for packet transmissions across the chip through only one hop wireless link channels. Secondly, why not also provide an architectural flexibilities. This therefore reducing an area overhead as well as the chip design complexities. That beyond a certain source to destinations, performance enhancement by using wireless channels is greatest as compared with the multi-hop traditional metal wires. So this layout shows an example of 64 core of mesh one architectures overlaid with 4 by 4 or 16 number of radio hubs. So these one architectures can be seen as two tiers or two layers topological structures where the conventional NOC wire is at the lower layers, meanwhile the wire plane is at the upper layers. As can be seen at the upper layers of the wireless plane, the MAC protocols implements mechanisms for ensuring that all the radio hubs can access the wireless medium in reliable manners. And because it is shared, this MAC protocols is critical or crucial in determining the performance of wireless networks. This table summarizes the related works on MAC protocol, which can be basically classified into four main categories, and they are token-based control access, channelizations, random access, and hybrid protocols. There are many works in the literature that have adopted this coordinate access token-based approach uh, as the preferred MAC protocol for wine architectures. And in here, in this the radio hub nodes uh, and in these protocols the radio hub nodes are organized into logical rings where a token will circulating through the rings in order to find which radio hub is granted for transmission over the wireless channels. As for channelizations, multiple access techniques that grant access to the available various channels across the several radio hubs by using either TDMA, FDMA, or CDMA. In a random access links, every radio hub has an access to share the wireless channel, but without being dominated by any other radio hubs. An example for that is CSMA or Carrier Sense Multiple Access. Finally, the hybrid MAC is the combination of the various MAC protocols on what has been discussed just now. For example, in Replica, it combined the CSMA with the token passing as its MAC protocols. Meanwhile, this table summarizes the related works on window routing protocols, which can be classified into three main categories, and they are deterministics, oblivious, and adaptive routings. For deterministic routings, the routing path is completely determined by the source and destination addresses. In oblivious routings, multiple paths from source to destination are possible. However, the route pathway selection does not depending on the current status of the networks. And adaptive routing is preferable in several regions because of in adaptive routing approach, multiple paths from source to destination are also available. However, in addition, the routing path selection is further determined by the network's current status, such as hotspot region or congestion factors. Now, let's look into the problem statement for this thesis. From one hand, the MAC delay is one of the dominant factors in the overall delays in Winox. And most existing Winox is the daisy chain based unidirectional rings topologies with uses token passing procedure as access mechanism uh, to its wireless medium. This is due to its simplicity as well its collision-free protocols. However, the limitation of this approach is that the various channels access delay, which is caused by tokens collisions among the radio hub, which can result in a maximum token waiting time, especially when radio hub miss the token before the packet arrive. This therefore restricts the performance advantage of using the wireless channels for architectures. Further, reducing the MAC delay for runoff is crucially important to keep the latency advantage of the one-hop wireless capabilities. From the other hand, most of the architecture proposed in the literatures have uh, employed a regular topological structure to take advantage of their several advantages such as modularity, scalability, and its business. However, due to the limited wireless channel bandwidth, the radio hub are susceptible to congestions as the wireless channels is shared among all processing cores, and this therefore can lead to the possibility of the radio hub overloadings, which later can cause network congestions due to the multiple access that are requested to that particular wireless channels. In addition, from the parallelism standpoints, the bandwidth for our wireless channels is much less than the aggregate bandwidth for all wired interconnects. That also means the aggregate bandwidth for wired is far greater as compared with the wireless bandwidth. Therefore, to achieve the best one of performance, there is a necessity to devise routing mechanisms that can appropriately select either to use wired or wireless for its data package transmissions. The main objective in this thesis is to improve the performance of the mesh WANO architectures by improving the MAC protocol as well as its WANO packet routings. Therefore, the objective of this thesis are twofold. First is to propose bidirectional medium access control protocols for improving wireless access performance at the upper layers of mesh WANOs. Second is to formulate the distant aware routing mechanisms to improve network performance at the lower layers of the mesh WANO architectures. For research scopes, the investigated architecture is a mesh WANOC with a system size of 8 by 8 or 64 cores. And in that mesh architectures, all NLC routers have access to both wired and wireless channels. Single channel wireless is assumed to be available for WAN integrations. And for as a proof of concept, the proposed design are developed in C++ and System C with OOP approach, object-oriented programming approach, by employing the NOCSIM and NOCSIS simulators. Validation of the proposed works presented in this thesis are evaluated with both synthetic and benchmark traffics. And finally, evaluation matrices in terms of transmission latencies, node throughput, and energy consumptions. So this block diagram describes an evaluation framework for the simulation-based design space exploration of the proposed design. As an input, mesh WANOC interconnection configuration is defined in YAML file, and then our Noxian simulator is employed as the WANOC runtime engines, and afterward, the result and statistics can be obtained. Next, let's continue with the first proposed works, bidirectional MAC, or in short, BMACs. So this layout shows the two-tier mesh WANOC WANOC architectures with the proposed BMAX. And the proposed BMAC is at the upper layers of the mesh WANOC architectures, while the BMAC protocols is employed at the upper layers with BMAC mechanisms and the bidirectionalists, which are represented by the red arrows, to allow the token to serve the previous radio hub for using the wireless channel for data package transmissions. The protocol description of BMAC is shown in these algorithms. And this protocol begin with the condition of checking requests from the subsequent radio hubs. Okay? When the next request of the current radio hub is come from its previous neighbor, and also the next neighbor is not requesting, the BMAC protocol is therefore executed. This BMAC algorithm allows the change of token directions, turn the token according to the last request radio hubs. Therefore, rather than going to full round, worst case full rounds, this technique can reduce the worst case maximum token time. Otherwise, if the condition is not satisfied, then the baseline token ring is adopted as the MAC protocol for WANOC. So the next presentation is about the second proposed works as my second objective, which is the distant aware with BMAC protocols. In short, it is called DA plus BMAC. This figure shows the conceptual design of DA plus BMAX on the mesh wire architectures, and DA plus BMAC is a joint schemes between the BMAC with DA. The proposed BMAC is at the upper layers of the wireless plane, as shown in the red layout. As the integration will be made, the proposed DA is at the lower layers of the wired plane, as shown in the blue layout. This proposed approach could improve the YNOC routings by balancing the data packets loads by tackling both uppers and lower layers. All right. So the protocol description for DA plus BMAC is shown in these algorithms. Well, first, the algorithm will compute the hop count distance of the communication pair from source to destinations that are requesting for transmissions. Then, the wired or wired selection is chosen based on a certain distance threshold. The wireless plan is selected when the hop count distance is beyond a certain distance threshold, which in this case indicating the long distance communications. And as as has been discussed in the previous algorithms, the BMAC algorithm is executed whenever there is a request from its previous radio hop. Otherwise, the packet will be transmitted through the wired pathway. All right, now let's look into the result and conclusions for this disease. This is the simulation setup that has been carried out for disease. This disease adopted 60 gigahertz circuit in the millimeter wave range, which implemented with 16 nanometer CMOS, which is as proposed as a URL. This transceiver design come up with 16 gigabit per second bandwidth, which are utilizing around 2 picojoules per bit and power dissipation and occupying around 0.3 millimeter square area footprint. For simulation result, let's first look into BMAC. And this graph summarizes the performance impact on the latencies, in particular, the performance advantage of BMAC over baseline is more significant in the sharper curve. And this is shown in graph B. On the contrary, the hotspot traffic pattern is employed to test BMAC abilities to handle the imbalance load. And as shown in D, hotspot traffic demonstrates some performance degradation as compared with the other traffic. And this is due to the traffic injection that is being concentrated around the hotspot nodes. This graph summarizes the performance impact on the network throughputs. Except for hotspot traffic, BMAC allows the network to reach at higher peak throughput as compared to the baseline as shown in A, B, and C. Well, next is about the simulation result for DA plus BMAC, which is under synthetic traffic. This graph summarizes the performance impact on the latencies. And as you can see from the graph, the improvement is depending on the communication patterns. And for all cases, DA plus BMAX perform significantly better uh, as compared to the BMAC and the baseline architectures. This graph summarizes the performance impact on the network throughput. And as a general trends, focusing on figure A, B, and C, the DA plus BMAC shows an improvement over The other two architectures, which are under random shuffle and transpose traffic scenarios. In contrast, as shown in D, DA plus BMAC can only provide a slight throughput improvement at network saturation in the hotspot traffic. Now let's look into the experimental result for Splash 2 and Parsecs benchmark traces validations. This result summarizes the performance impact under benchmark traces. And as can be seen, all graph shows a similar patterns for both benchmark traces, but with different PIR loads for BMAC and DA plus BMAC improvements. For both cases of the benchmark traffic scenarios, uh, the proposed DA plus BMAC approach shows an attractively better performance over the baseline and the MAC protocol on its own. This graph summarizes the energy consumption under benchmark traces. BMAC can provide better energy characteristics with its bidirectional MAC approach. And in addition, the plus BMAC can further improve the energy profile or characteristics when the distant overroute mechanism is integrated with the BMAC protocols. The next presentation is about the saturated load performance analysis. Uh, this result summarizes the normalized network throughput of the proposed networks. Except for hotspot traffic, all traffic scenarios reveal that BMAC can provide throughput improvement over the baseline design. Moreover, with the A plus BMAC approach, the improvement in the network throughput at the saturated load is higher. This result summarizes the performance speedup in terms of network throughput. Also, except for hotspot traffic, for all cases, the proposed BMAC design speedup is higher than the baseline mesh one architectures. Interestingly, the proposed joint scheme or approach, the A plus BMAC can provide an apparently better speedup as compared with the BMAC and the baseline design. On top of that, as can be observed, the throughput speedup can be improved up to 11x for synthetic traffics, random, okay, 10x for bands, and 11x for fluid and make workload. All right, the next analysis is about an energy consumptions at the saturated load. This result summarizes the normalized energy consumption of the proposed works. For all traffics, the proposed BMAC is capable of providing an energy reductions with respect to the baseline design. Further, the energy reduction is more significant for DA plus BMAC joint scheme. And this result summarizes the percentage of energy savings of the proposed works. And for the shuffle synthetic graphics, up to 8% and 50% energy savings can be obtained when BMAC and DA plus BMAC utilized accordingly. For splash to bonds, the proposed BMAC and uh, DA plus BMAC can achieve up to 5% and 14% energy saving respectively. And finally, 5% and 13% of energy can be saved for BMAC and DA plus BMAC. Accordingly, that is for fluid animate benchmark traces. This result showing that the proposed BMAC and the plus BMAC is also energy friendly for the investigated mesh WAN architectures. In conclusion, this thesis has presented the bidirectional MAC with the distant aware routing mechanism, which has been validated on 64 cores based on architecture networks. Therefore, this thesis has provides two main research contributions. First is the BMAC protocol for mesh WAN architectures, and second is the DA plus BMAT routing uh, for the mesh RANOC architectures. There are several works that can be carried out for this disease. First is considering a back request of more past radio hubs. Second, further, moreover, and finally, that. Thank you.